We just finished question number 40, so let's go back up to the top of this page. And we'll start with question number 41. Alright, if the measure of angle A is 48 degrees, if they're going to give me data, I'm going to label my diagrams. So the measure of angle A is 48 degrees, and the measure of angle C is 32 degrees. Then what is the measure of angle B? Well, let's take a look, class. What else do we know? If the measure of angle A is 48, the intercepted arc for that inscribed angle is DC. We double 48. That means this is 96. And you know what? I'll just do this as well. Inscribed angle C cuts out arc AB, so 32 times 2 is 64. Those are two things I know. And look at angle B. Angle B, inscribed angle B, cuts out the same arc as angle A. It's arc DC. That means the measure of angle B has to be 96 divided by 2, and that's going to also be 48 degrees. What about arc DC? Oh, the cool part is we already figured that out, and I'll just write how we figured that out. We figured out that was 48 times 2, and that is 96 degrees. What is the value of x? We've got two ways to solve this. We figured out that the measure of angle B is 48 degrees. We know that the angles of a triangle add up to 180, so we could find this angle right here, and then since these two angles are supplementary, they add up to 180, you could subtract this angle from 180 and find the measure of this angle, which would give us the value of x. There's one way to do it. Here's another way to do it. Look at our property of intersecting chords inside of a circle, or angles inside of a circle. This chord 64 plus 96 can be used to find this angle measure. So we're going to know, we've learned this, the measure of angle, let's call this, actually you know what, let's just do this. We can say that x is equal to 1/2, and you add those two arcs together, 64 plus 96. That's 1/2 of 64 plus 96 is 160, and that means the value of x is equal to 80. Now in this case I can leave my answer as the value of x because that's what I'm looking for. In previous questions, if I got a value for x, I always rewrite the answer and write down what am I looking for. In this case, x is 80 degrees. Or actually, x is 80 because the degrees is already on the variable. Questions 44 and 45. If the measure of angle B is 49 degrees, hold on here, my computer decided to just stop working for a second. There we go, 49 degrees. And the measure of arc AB is 176 degrees, then what is the measure of angle C? Well, angle C is an inscribed angle. It cuts out arc AB, which is 176. That means to find the measure of the angle, we just divide 176 by 2, and we end up with 88 degrees. I'm going to go ahead and label that 88 degrees. 45, what is the measure of arc BC? Well, I'm going to have to figure out either arc AC and then subtract the two known arcs from 360, or I can find the measure of angle A and then just double it, because this is an inscribed angle and this is its intercepted arc. I'm going to do it that way. So let's just go ahead and figure out. We got 180 minus 49 minus 88. That's going to give us the measure of angle A, which is 43 degrees. And now we know that to find the measure of arc BC, we're going to double that. So 43 times 2 is 86 degrees. And there is our answer. Now if you wanted to finish this question, you can now figure out the measure of arc AC. That's going to be 49 times 2, which is 98 degrees. Let's just fill the whole thing out. And we can check our answer and see if we're looking good here. Those degrees around the circle better add up to 360. 176 plus 86 plus 98 equals 360. Boom, got our answer correct. All right, questions 46, 47, 48, and 49. 4 questions here. If FG is a diameter, well, that tells us a lot. If FG is a diameter, then what is the measure of angle DFG? Well, the first property we have to remember is if FG is a diameter and triangle DFG is inscribed in the circle, then because this is a diameter, this has to be a right angle. And the same thing applies to triangle FBG. If this is inscribed in a circle and the hypotenuse or one of the sides is a diameter, then that's the hypotenuse, and that means that's a right angle. So that's the thing we have to know, class, in order to solve this problem. So the measure of angle DFG, well, that's part of a triangle. The angles of a triangle add up to 180. So I'm going to take 180 minus 90 minus 63. And that's going to be equal to 27 degrees. So I know this is 27 degrees. What is the measure of angle FGB? Same strategy. I'm going to take 180. I'm going to subtract our known angle of 90 and our known angle of 72. And that's going to be 18 degrees. Again, computer thinking. There we go. Stop thinking. That's 18 degrees. Notice I'm labeling as I go. This is important because the next question is, what is the measure of arc DFB? DFB. If you cover this over, if you cover that arc, or cover everything but that arc with 3x5 cards, you'll find that this is the central angle. I'm sorry, not central. This is an inscribed angle that cuts out that arc. We have to add those two together. So it's going to be 63 plus 18. And that's going to be equal to 81 degrees. So this inscribed angle is actually 81 degrees. We have to now multiply that by 2 to get the measure of the intercepted arc, which is 162 degrees. And then what is the measure of FDG? The arc FDG, well, that's made by a diameter. We know a diameter cuts a circle in half. So that means we know this one is, let's just make a little note here. This is a semicircle. And that means it is 180 degrees. Now look, you can't add those two up and get 360 because there's overlap here. Take a look. DFB is right here and FDG is right here. They actually overlap here, and then neither one of them is looking at arc GB. So don't fall in the trap of trying to add those together and go crazy thinking, how come I don't have 360? Because those two arcs don't represent the entire circle. All right, down to number 50, 51, 52. What is the measure of angle R? This is an inscribed quadrilateral, inscribed in a circle. That means opposite angles are supplementary. So the measure angle R is 180 minus 86, which is equal to 94 degrees. What is the measure of angle S? Same property. S and W are supplementary, or they add up to 180. That means we can take 180 and subtract 109. We're going to get 81 degrees. Let's check our math there. That is not correct. How about 71 degrees? That makes more sense. Okay, and the final question, what is the measure of arc RWT? Well, that is the intercepted arc. Actually, you know what? I should have labeled my triangle here. I mean, my quadrilateral here. Let's label that. This is 94 degrees. This is 71 degrees. And again, arc RWT is the intercepted arc of inscribed angle S. That means to find the measure of that arc, we just take 71 degrees and multiply it times 2. And we're going to end up with 142 degrees. Last question in this column. The tire has a radius of 41 centimeters. How far will the tire travel with a 35-degree rotation? When you say how far, we're talking about not area, we're talking about circumference. If this tire drives, if I had a line right here, and I drove until my tire just turned 41 degrees, this would be how far I traveled. That's an arc length. So the first thing we have to figure out is, what's the circumference of this tire? Circumference is 2 pi r, which is 2 pi, the radius is 41, and that's going to be equal to 82 pi centimeters. And now our normal procedure is we take the total circumference of 82 pi and we figure out how much of that circumference do we want. What's our fraction? We're going to travel 35 degrees out of a total of 360 degrees. Let's put that in our calculator. 82 pi times parenthesis 35 divided by 360, close parentheses, equals 25.04. So it's going to be rounded to 25.0. So we're going to travel approximately 25.0 centimeters. That is the length of our arc, which is also how far we're going to move on the ground if our tire rotated 35 degrees.